Hey guys, and welcome back to this video provided by Alabama Science in Motion on how to do the lab journey of a physics student virtually. Now, one of the things you're going to have to be able to do in order to complete this lab is you're going to have to do this pre-lab. Now, most of the time when we do a pre-lab, it's literally just that. But in this case, you actually need to be able to answer these questions in order to complete the lab. So if you're unable to answer these for some reason or have difficulty, there is another video where I go through and I explain the answers to these 10 questions, but we'll leave that to the teacher based on whether or not you actually need that video. So in general, when we're looking at this lab, one of the things we're going to do is essentially assume this basic coordinate system of north, south, east, and west. That's pretty terrible west or south, huh? Anyway. But one of the things that we're going to have to also do is this. We're going to call east 0 degrees in doing the lab, and then 90 degrees, 180, and I think you've got the general rundown here. At least this is how our calculations will be based upon this. So you may see, for example, a question that says something about somebody walks 200 miles east. Hopefully you'll draw your line straighter than this. But again, that is while we're doing it in a computer. So in order to do this lab, so the first part's essentially Cartesian coordinates. So what you're going to do is this. You're going to go to the Google file that your teacher gives you, and it's going to look like this, Journey of a Physics Student. You'll be given the map. Here's the one that says Cartesian coordinates. And I'm going to show you kind of how to actually do this in this Google slide that you've got. Now, depending on how your teacher gives it to you, one of the first things you may have to do is actually go through and save a copy of this so that you're able to edit it. So just kind of keep that in mind if necessary. But let's go back for a second and take a look at the instructions here. So trip number 1, I'm supposed to go 472 miles east. And you may be looking at this going, well, how do I know 472 miles? Well, if we were doing this with paper and pencil, we'd use a ruler and it'd tell us and it'd tell us that 1 centimeter is 118 miles. Well, we've got this grid overlaid, and so each block is 118 miles by 118 miles. So in the case of this first calculation, 472 miles, and you can do this for all of them, 472 divided by 118, and that tells us we're going to go 4 blocks to the east. And now let's figure out how many blocks north that we're going to go on this map. So 708 divided by 118, and this is how you can do all your calculations. One of the things, if I was you, I might go through, so this is 6, I might actually go through and go ahead and just knock all these calculations out to begin with, and that way it'll kind of make doing this lab fairly easy. So in the instructions, it's actually very clear, and it tells us we're going to do dashed blue lines for our east and west movements for this part, and we're going to draw dashed red lines for our north and souths. And so essentially what we're going to do is this. We're going to go over 4 blocks, I think it said east, and then we'll go up 6 blocks west. Now I've already messed up because I didn't do my colors and my dashed lines. And then it says we're going to go down here and let's see, where's it at? A solid green line when we connect those two. So we'll end up doing, that'll be blue, this one will be green. Wow, I'm totally messing that up. Red, so blue, red, and then the solid green line to connect them. So let's just go do it actually in Google. Now, when you pull it up, it's probably going to be like this, and that's kind of small to be looking at. So what I'm going to do is I'm going to actually go up, and I'm going to go and zoom. I'm going to zoom into 100%. You can zoom in more if you need to. I already have one random green line on my paper, so I'm going to erase that one for the moment. And so starting in Montgomery, so I'm going to go up to the top, and I'm going to get a line. I want an arrow, actually. And I'm going to start in Montgomery, Alabama, and go 1, 2, 3, 4 blocks to the east. Now that line's kind of small, so I'm going to go up to the top. I'm going to change it to a 4, and I'm going to change that one's supposed to be blue, and I'm also going to change it to a dashed line. So now I've got my first line drawn, and now I'm going to go to the end of that one, and I'm going to go 6 blocks north. So this time, once again, give me an arrow. I'm going to go up 1, 2, 3, 4, 5, 6. And I think you've already got a pretty good idea now how to do your drawings. And this one should be a red line, and I'm going to make it a little bigger. I'm going to go with 4. And this one's also a dashed line. So that's easy. And now the last thing I'm going to do is I'm going to draw another line, and this one's going to be solid green, and I'm going to use it to connect the two ends. So we'll go up here to the top, and 4, and give me a green, please. All right, so I've actually finished my drawing for the first part. And what you're going to do drawing-wise is you're going to continue around this map doing this for every single displacement that you've been given. Like the next one is west and north, west and south. You should have a pretty good idea of what you're going to be doing here.
Hey guys, sorry for this little interruption in here, but I got scared for a second after kind of watching this video initially that you might like get confused about and think that every line is going to start. So I'm looking at the monitor here, that you're going to start each time from Montgomery. But make sure you understand, the next one, I think if you do your calculations, it's going to come over 6 blocks to the west. Make sure that you understand that each new line you draw it's going to start wherever your last line finished. So where I'm up in Pennsylvania, this next line is going to come over 1, 2, 3, 4, 5, 6. And then it's going to also go up 1 from there. And then what you'll do is make your connecting line. Of course, I'm sitting here not doing my colors and everything like I work to. For example, that one should be blue. Let's 4 dashed. But anyway, you got the idea, I hope. So anyway, make sure you understand, though, that you start each new section or each new line starts wherever the last one ended. So essentially what's going to happen, that's why this is called the journey of a physics student, is because we're going to kind of make this move around the map, up, down, left, right, over. And ultimately, if you've done everything right, you should end up somewhere on this map. Not in the ocean, but you should actually end up on this map somewhere. And that's going to be kind of the easy way to be like, hey, did you end up in Baton Rouge, Louisiana, or Jackson, Mississippi? I'm not going to tell you. Anyway, I just wanted to clarify that, and we'll kind of splice back in this video. Thanks for watching, guys.
Now, the part of this where it could be a little bit more complicated. One, you're going to have to make some calculated measurements, and that's what the pre-lab was about, learning how to make the calculations. So I'm not going to cover that explicitly here, but I'll have in the other video a little bit more about how to do that part if you get stuck on it. So how to calculate the magnitude of this line. And I'll go and give it away. It's really pretty easy. It's all we're doing on this is Pythagorean. But now, how can we actually measure it? Because you should be looking on this like, Mr. Cole, do we have like a virtual tape measure? Well, for the angle, we actually do have a virtual protractor. So I went to Google Extensions, and I went to the Chrome, and you can download. It's a free protractor. So I'm going to draw it, and I'm going to put this protractor down here at my Montgomery location. And now look at what you can do. You can sit here and pivot this thing around. And so I'm going to measure my angle. And I think I've got it pretty close. And it looks like the angle of that line is 56.2 degrees. So I'm going to go over to my measured angle, and I'm going to write 56.2 degrees. Now, you may have to ask like an administrator at the school to let you add that protractor, but it is a very handy little function on there. But I can show you another way that we can figure it out. It's just not as good as using the protractor app. So now we also need to figure out how long it is. And this is when you should be going, all right, Mr. Cole, how about a nice virtual tape measure? Well, they make some of those, but for what we're doing, I'm going to close that and get that out of the way. It's actually not as convenient. So I'm going to do something. I'm going to just drag this line. Notice I'm not changing the size of the line. If you do that, you'll completely goof this. But I need to measure that line. And in order to measure it, I either need it going straight vertical or straight horizontal to measure it. So click on the line and go to Format. And now you'll see where it says Angle. And I'm going to tilt this thing till I get it completely horizontal. So by default, it starts out by telling me I'm at 180 degrees. And I'm going to keep tilting, tilt. Ooh, that's pretty good. Till I get it horizontal. Now I'm going to try and do something here. I've got it horizontal. So it says 237. So I just wonder, what does that difference come out to? So 237 minus 180 was where I started. So I was at 57 degrees. And so if you remember, my protractor came out to 56 degrees. So that wasn't too bad. So that's one way you could measure the angle without using that little neat protractor extension that I added to mine. Hopefully you can get that because it's handy. Matter of fact, if you look, I don't think I'm dead horizontal. So I'm going to go back a notch, 236, and hey, that's even better. So that actually matches the protractor. So now what I want to do is this. I want to measure how long this line is. And I'm looking at it, and so that's 1, 2, 3, 4, 5, 6, 7, and well, if that's middle, I'm going to say that that's about 7.2 long. Now, if you remember, we know 7.2 times each block was 118. And so now I'm going to say that that line is, let's just say 850. So let's go back to our data table, and I'm going to say that this is 850 miles. And now you can go back and do the calculations. You'll use Pythagorean in order to get these two calculations. And then you'll use the tangent function in order to calculate this side over here. So anyway, and then so we've got a pretty good idea. What you need to do now is like go back to your map. After you do this, now that's pretty easy. You could go back and just click. Actually, I'm going to do this. I'm going to go back and I'm going to return it to where it defaulted at 180. And I'm just going to slide this green line right back to where it was. It usually kind of auto aligns. And now the next thing I would do is kind of continue following with my map. Continue following with your instructions. And next would be 708 and 118. So anyway, there's a place in your data table to do all your calculations. And so I'm going to leave you with this part, and then I'll make a second video where we'll actually go through and talk about the polar coordinates, how to do this, but it's very easy in the second part. So anyway, see you in the second part of this video to do the polar coordinates. Bye.